You've been organizing SharePoint like it's 2015, and that filing logic is about to become a liability, but in reality it's not a storage problem. It's a structural failure that kills search, breaks compliance, and undermines every Copilot rollout. Industry audits consistently find the same pattern. Organizations only discover this gap after a failed audit or a Copilot hallucination. Custom AI document models close that gap automatically, and in 2026, the tool that does it just got renamed for the fourth time in 6 years. Your SharePoint data is a liability. Your IT team probably thinks your SharePoint estate has a storage problem. More files, more sites, more noise. But that diagnosis misses the actual disease. The real problem is that most of those files carry no business metadata at all. They're unstructured, untagged, and invisible to every system that needs to act on them. Organizations create over 2 million SharePoint sites every single day. They upload more than 2 billion files daily. And most of those uploads land with nothing more than a file name and a timestamp. No contract type, no expiration date, no sensitivity label, no retention category. Just a document sitting in a folder, hoping a human remembers what it is and where it belongs. That isn't messy. That's a liability hiding in plain sight. When documents lack consistent metadata, employees spend hours hunting for the latest approved version or recreating information they cannot find. Analysts have measured this friction as a direct productivity loss. In distributed organizations, multiple teams maintain parallel versions of the same materials in siloed sites or personal OneDrive accounts. The same contract lives in 3 places, each with different edits, and nobody knows which one is authoritative. Somebody rewrites the work from scratch because they couldn't find the original. That's not laziness, that's a metadata failure. The folder-based mental model is the root cause. Folders assume that people know what they're looking for and where it lives. They assume a single hierarchy can represent every possible way a document might be discovered. But modern work doesn't start with navigation, it starts with context. A project manager needs every contract that expires in the next 90 days, regardless of which site stores it. A legal team needs every document containing a liability clause above a specific dollar threshold, without opening each file manually. Folders can't answer those questions, metadata can. But the problem runs deeper than lost time and duplicated work. Microsoft 365 Copilot and other generative AI tools rely on underlying content signals to return relevant, trustworthy responses. When documents lack accurate metadata or live in haphazard locations, semantic search and AI-driven retrieval struggle to surface the right context. Every missing or incorrect metadata field degrades the signal that AI systems use to reason about your content. Your Copilot investment becomes inconsistent and difficult to trust, not because the model is broken, but because the ground beneath it is. The metadata gap is also a genuine compliance and risk concern. Regulators and courts expect defensible retention, disposition, and e-discovery practices. Retention policies and labels in Microsoft Purview are designed to help organizations retain content for required periods or delete it when it is no longer needed, but these controls rely on being able to identify which content falls into which category. When documents lack classification that differentiates records from working copies or regulated data from non-critical content, retention settings may be applied broadly or not at all. That creates both over-retention risk and premature deletion risk. In e-discovery and litigation holds, metadata becomes even more critical. Metadata provides creation and modification timestamps, authorship, file paths, and message headers, all of which are needed to reconstruct events and demonstrate chain of custody. Best practices for defensible e-discovery emphasize preserving metadata using forensic-grade tools, documenting the chain of custody, and auditing metadata before and after processing. If SharePoint content spreads across uncontrolled sites, personal OneDrive locations, and shadow repositories, and if the metadata is inconsistent or incomplete, legal teams may struggle to identify, preserve, and produce relevant materials in a defensible manner. Security and privacy risks are similarly amplified. SharePoint and OneDrive provide strong security capabilities, including encryption in transit and at rest, two-factor authentication, conditional access, and data loss prevention policies. However, DLP rules, sensitivity labels, and conditional access rely on understanding which documents contain sensitive information. Without reliable classification, organizations may either over-restrict access and hamper collaboration or under-protect sensitive documents and lead to accidental exposure. In an environment with weak metadata, even powerful tooling cannot reliably enforce the principle of least privilege. Hybrid work has fundamentally altered how teams create and share information, and traditional folder hierarchies no longer align with how people work in Teams, SharePoint, and other collaborative tools. Modern collaboration centers on projects, channels, or topics that cut across organizational structures, leading to documents stored in multiple contexts simultaneously. Users expect to find information through search, recommendations, or AI assistance, rather than working through deeply nested folder trees. This shift exposes the limitations of purely location-based organization and shows why content must carry rich descriptive metadata that allows discovery and reuse regardless of where it physically resides. At the same time, AI is becoming embedded in everyday work via Copilot experiences in Microsoft 365, which use an intelligence layer sometimes described as work IQ to connect individual and organizational knowledge. This intelligence layer leverages existing metadata, signals, and user interactions to provide relevant suggestions, summaries, and answers. If that underlying content is poorly governed, with inconsistent labels or incomplete metadata, AI systems may surface obsolete or inappropriate documents, undermining user trust and potentially exposing sensitive information. The metadata gap becomes a barrier to realizing the promise of AI-accelerated hybrid work, reinforcing the argument that unmanaged SharePoint data represents not only a latent liability, but also an opportunity cost. And one level deeper, the problem isn't even the absence of metadata, it's the absence of a metadata strategy. Most SharePoint environments have columns. They have content types, they have term sets that somebody built 3 years ago and abandoned. What they don't have is a living, governed, business-aligned taxonomy that connects document content to automated action. Without that strategy, any AI tool you deploy will be guessing. And guessing at scale is expensive. Consider what happens when a new employee joins your legal team. They need to find every active contract with a specific vendor. They open SharePoint, go to the legal site, and find a folder called Contracts 2024. Inside that folder are subfolders for each quarter. Inside Q2 are files named Contract Final V2, DocX, Contract Final V2 mic.docx, and Contract Final signed.pdf. None of these files have metadata columns populated. The new employee opens each one, reads through pages of legal text, and manually compiles a list. This process takes 4 hours. It should take 4 minutes. The same scenario plays out in finance when month-end close requires reconciling invoices against purchase orders. The accounts payable team searches through email attachments, Teams chats, and personal OneDrive folders because the SharePoint library has no vendor name, no PO number, and no approval status in the metadata. They open each PDF, read the header, and copy numbers into a spreadsheet. The process is not just slow, it is fragile. One wrong copy-paste creates a reconciliation error that takes days to untangle. IT teams often respond to these complaints by adding more storage or faster search, but faster search of bad metadata still returns bad results. A search for contract in a 10 terabyte SharePoint estate returns 10,000 files, most of them irrelevant. The user adds more keywords, narrows the date range, and still cannot find the specific document they need. Search relevance depends on metadata density. Without metadata, search is just a faster way to browse garbage. The cost compounds over time. A contract that auto-renews because nobody tracked the expiration date costs real money. A sensitive document that leaks because it was never classified costs reputation and regulatory fines. A Copilot response that cites an obsolete policy because the current version lacked metadata costs user trust. These are not edge cases. They are the daily operating reality of organizations that treat SharePoint as a filing cabinet instead of a knowledge system. The opportunity cost is harder to measure, but just as real. Organizations that govern their metadata can query their document estate like a database. They can ask which vendors represent the highest liability exposure. They can ask which contracts expire in the next quarter and require renewal decisions. They can ask which policies have not been reviewed in 2 years and need updating. These questions transform document management from a cost center into a strategic capability. The metadata gap is what prevents most organizations from making that transformation. It keeps SharePoint in the filing cabinet era while competitors move into the intelligence era. The metadata foundation. Before you can fix the structure, you need to understand what the structure actually is. Most people define metadata as data about data. That definition is technically accurate and practically useless. For governance and automation purposes, metadata is better understood as the structured descriptors that let systems and people understand, organize, and act on information. For a document, this includes simple attributes like title, author, and creation date, as well as business-specific properties like contract type, client name, region, sensitivity level, or retention category. Metadata provides the context that allows documents to be grouped, searched, filtered, and processed in a consistent way, especially when stored at scale in repositories like SharePoint. Without a coherent metadata strategy, content becomes opaque. Even basic questions become impossible to answer without manual review. Which contracts expire in the next 90 days? Which proposals contain governing law clauses for California? Which HR files are subject to a 7-year retention rule? Folders can't answer those questions, only metadata can. There are many ways to classify metadata, but one useful distinction is between technical metadata and business metadata. Technical metadata describes system-level properties like file size or encoding, and it is often generated automatically by systems. Business metadata captures meaning from the perspective of business processes and regulatory obligations, and it typically requires explicit design and governance, including agreed vocabularies and rules for how and when to apply labels. Standard schemas, such as Dublin Core, offer generic elements that can serve as a starting point, but organizations usually need custom schemas that reflect their specific use cases, industries, and regulatory requirements. This is where SharePoint's managed metadata infrastructure and intelligent document processing create real value. SharePoint has long provided a rich set of metadata mechanisms, including site columns, content types, and the managed metadata service, which allows organizations to define and centrally manage vocabularies of terms. Managed metadata enables the creation of term sets that can be shared across site collections, providing consistent choices for fields like department, product line, or document category. This shared taxonomy not only improves user experience when tagging content, but also supports more reliable search refiners, navigation, and policy targeting. Content types extend this model by bundling together a set of columns, templates, and workflows for a specific type of content, such as a customer contract or standard operating procedure, which can then be reused across libraries and sites. Taxonomy governance is critical to ensuring that these structures remain usable and relevant over time. Frameworks for taxonomy governance emphasize the need for cross-functional involvement from business units, IT, and information management, clear ownership of term sets, and defined processes for adding, modifying, or deprecating terms. If term sets grow organically without oversight, they can become cluttered and inconsistent, eroding the benefits of structured metadata and confusing end users. Conversely, a well-governed taxonomy aligned to business domains can form the backbone of automated classification and retention policies, particularly when paired with AI-based systems that can infer metadata from document content. But here's the problem. Most organizations skip the taxonomy step and jump straight to the AI. They think a machine learning model will somehow invent their business logic from scratch. It won't. AI can recognize patterns in documents, but it needs a target vocabulary to populate. It can extract an expiration date, but it needs to know which column to drop it into. It can classify a document as sensitive, but it needs to know which sensitivity label your organization uses. The model isn't the hard part. The taxonomy is, and if your taxonomy is broken, your model will be too. Managed metadata service is the engine that makes taxonomy scalable across your tenant. It stores term sets in a central service application, making them available to any site collection that subscribes to them. When your legal team defines a term set for contract types, every SharePoint site can use those same terms without recreating them. When your HR team updates a department list, the change propagates automatically to every library that references it. This centralization is what prevents the organic sprawl of inconsistent labels that destroys metadata quality over time. Content types add another layer of structure. A content type bundles columns, templates, and workflows into a reusable package. When you define a customer contract content type with columns for counterparty, effective date, and governing law, you can attach that content type to any library in your tenant. Users see the same column structure, the same document template, and the same retention workflow regardless of which site they are in. This consistency is what makes enterprise governance possible. Without content types, every site owner invents their own column names, their own data formats, and their own business rules. The result is a metadata Tower of Babel where vendor in one site means counterparty in another, and no system can correlate them. Site columns are the individual fields that make up a content type or a library schema. Each site column has a data type, a default value, and a set of allowed values. When you define a site column for contract value as currency with a minimum of 0, you prevent users from entering text or negative numbers. When you define a site column for contract type as a managed metadata field tied to a closed term set, you prevent users from inventing new contract types on the fly. These constraints are not limitations. They are the guardrails that keep metadata clean enough for automation. The relationship between these elements matters. Term sets define the vocabulary. Site columns define the field structure. Content types bundle them into reusable packages. Libraries apply them to real documents, and syntax models populate them automatically. If any layer is missing or broken, the whole stack fails. A beautiful model with no target columns has nowhere to write its extractions. A perfect taxonomy with no model has no way to populate itself. A governance policy with no classification has nothing to enforce. These 4 layers, taxonomy, columns, content types, and models, must be designed together. Unfortunately, most organizations design them separately if they design them at all. The SharePoint admin creates generic libraries with default document content types. The business user uploads files without tagging them. The compliance officer writes retention policies that apply to everything because there is no classification to target. The AI team deploys Copilot and wonders why it returns irrelevant results. Each group is doing their job in isolation, and the isolation is what creates the gap. Governance, compliance, and Copilot readiness. The metadata gap isn't only a productivity issue. It is a genuine compliance and risk concern that sits at the intersection of governance trends and AI readiness. Regulators and courts increasingly expect organizations to demonstrate defensible retention, disposition, and e-discovery practices, particularly in regulated industries or jurisdictions governed by frameworks like GDPR, CCPA, and ISO 27701. Retention policies and labels in Microsoft Purview are designed to help organizations retain content for required periods or delete it when it is no longer needed, but these controls rely on being able to identify which content falls into which category. When documents lack classification that differentiates records from working copies or regulated data from non-critical content, retention settings may be applied broadly or not at all. That increases both over-retention and premature deletion risk. In the context of e-discovery and litigation holds, metadata becomes even more critical. Metadata provides details such as creation and modification timestamps, authorship, file paths, and message headers, which are needed to reconstruct events and demonstrate chain of custody. Best practices for defensible e-discovery emphasize preserving metadata using forensic-grade tools, documenting the chain of custody, and auditing metadata before and after processing to avoid challenges to evidence integrity. If SharePoint content is spread across uncontrolled sites, personal OneDrive locations, and shadow repositories, and if the metadata is inconsistent or incomplete, legal teams may struggle to identify, preserve, and produce relevant materials in a defensible manner. So the lack of structured metadata increases litigation risk and the cost of discovery exercises. It also amplifies security and privacy risks. SharePoint and OneDrive provide strong security capabilities, but DLP rules, sensitivity labels, and conditional access rely on understanding which documents contain sensitive information. Without reliable classification, organizations may either over-restrict access and hamper collaboration, or underprotect sensitive documents and lead to accidental exposure. Governance practices in the Microsoft 365 environment have been evolving to address both the scale of content and the emergence of AI-powered experiences. Emerging trends include more granular controls for regulating which content can be surfaced by AI assistants and tenant-wide search, reflecting both privacy concerns and the need to respect regulatory boundaries. One notable feature is restricted content discovery, which allows administrators to prevent content from specified SharePoint sites from appearing in organization-wide search and Microsoft 365 Copilot Business Chat, while still permitting users to access documents they own or have recently interacted with. This capability reflects a broader recognition that AI experiences introduce new governance dimensions. Organizations must manage not only who can access a document directly, but also how content can be discovered or summarized indirectly by AI tools. Governance strategies must cover both traditional controls around permissions and newer controls around AI visibility, ensuring that sensitive or highly regulated content is not surfaced in unintended contexts. At the same time, Microsoft messaging around hybrid work and AI emphasizes that organizations which invest in governing and organizing their information will gain a competitive advantage as they can more effectively use AI to drive productivity and innovation. The metadata gap thus sits at the intersection of governance trends and AI readiness. It is the single biggest reason your Copilot rollout will underwhelm, not because the AI is weak, but because the ground beneath it is incomplete. Copilot relies on metadata, permissions, and information architecture to return relevant, trustworthy responses. When documents lack accurate metadata or are stored in haphazard locations, semantic search and AI-driven retrieval struggle to surface the right context. The metadata gap becomes a barrier to realizing the promise of AI-accelerated hybrid work, and unmanaged SharePoint data quietly becomes a liability that most boards do not see coming. There's a secret weapon Microsoft built for this, and most tenants haven't turned it on yet. Restricted content discovery is one example of how governance is evolving to address AI-specific risks. Administrators can configure this feature to prevent specified SharePoint sites from appearing in organization-wide search and Copilot Business Chat, while still allowing direct access to users who own or have recently interacted with the content. This is not about blocking access, it is about controlling discovery. A site containing merger negotiations should not surface in a Copilot query from an intern who happens to have read permissions. The metadata and permissions layer must govern not just who can open a document, but who can discover it through AI. ISO 27701, GDPR, and CCPA all impose obligations on data minimization, purpose limitation, and transparency. These frameworks require organizations to know what personal data they hold, where it resides, and how long they keep it. A SharePoint environment with no metadata cannot answer those questions. When a data subject requests erasure under GDPR, the organization must identify every document containing that person's information. Without metadata tagging for personal data types, this becomes a manual search across millions of files. The cost of compliance scales directly with the metadata gap. The same logic applies to records management. A record is not just any old document. It is evidence of a business transaction or decision that must be preserved for a defined period and disposed of according to a legal authority. Records management requires classification that distinguishes records from working copies, transitory communications, and reference materials. Without that classification, organizations either over-retain everything accumulating storage cost and litigation risk, or under-retain, destroying evidence they later need. Metadata is the mechanism that makes records management precise, defensible, and auditable. Even basic information security relies on metadata. Conditional access policies can enforce multi-factor authentication for sensitive documents, but only if the system knows which documents are sensitive. Encryption policies can apply stronger algorithms to regulated data, but only if the system can identify regulated data. The principle of least privilege, granting users the minimum access necessary for their role, depends on understanding what each document contains and who should see it. Metadata makes those distinctions machine-readable. Without it, security policies become blanket rules that either block legitimate work or leave gaps that attackers exploit. Copilot readiness is the final and most urgent reason to close the metadata gap. Microsoft has enhanced Copilot's ability to reason over SharePoint metadata as of Ignite 2025. Copilot can now distinguish between similar documents by understanding their classification, department, project associations, and custom tags. When grounded on libraries with populated metadata, organizations see tangible improvements in response quality and relevance. For example, asking Copilot to show the latest client proposals for the healthcare vertical now returns accurate results because it understands both the content and the metadata tags indicating industry vertical, status, and date. Without metadata, Copilot is just a fast way to find the wrong answer. What intelligent document processing actually means. The weapon isn't Copilot itself, it's the layer underneath. Intelligent document processing, or IDP, refers to software capabilities that capture, transform, and process data from documents using AI techniques such as computer vision, optical character recognition, natural language processing, and machine learning. IDP solutions ingest documents in various formats, including emails, PDFs, Word files, and scanned images, and convert them into structured data that can be analyzed, categorized, and integrated into downstream systems and workflows. A key goal is to automate the extraction of relevant information, such as invoice numbers, contract dates, or customer details, and to classify documents according to type or business process, which reduces manual data entry and classification work. At a technical level, IDP systems combine several components. Optical character recognition transforms images of text into machine-readable text, enabling the processing of scanned documents or photographs of physical forms. Natural language processing techniques interpret the semantics and structure of the text, identifying entities, relationships, and topics that help classify documents or extract key value pairs. Machine learning models, often trained on labeled examples, learn to recognize patterns in document layouts and content, allowing them to handle structured, semi-structured, and unstructured documents. Over time, models can be tuned to specific domains, improving accuracy for particular types of documents or industries. Understanding the nature of the documents being processed is needed to design effective IDP solutions. Structured documents, such as standardized forms and invoices with consistent layouts, are relatively straightforward for extraction engines because fields appear in predictable locations and formats. For these, structured document processing models can map specific regions of a page to named fields, achieving high accuracy with relatively little training data. Semi-structured documents combine fixed and variable elements. Examples include purchase orders where line items vary, but the header structure is consistent, or invoices from multiple vendors that follow similar patterns but differ in detail. Unstructured documents such as contracts, policies, memos, and correspondence lack fixed layouts and rely heavily on linguistic cues and context, making them more challenging to parse reliably. The business case for intelligent document processing is grounded in both cost savings and risk reduction. By automating repetitive tasks such as data entry from invoices or manual tagging of documents, IDP reduces human effort and speeds up business processes, from accounts payable to contract onboarding. AI-driven classification and extraction can also improve accuracy relative to manual processes, which are prone to errors, especially when volume and complexity are high. Over time, the data extracted from documents becomes a valuable source for business intelligence and analytics, enabling organizations to derive insights from previously inaccessible, unstructured content. Studies have shown how AI-driven automation can transform employee productivity and accelerate business results by freeing knowledge workers to focus on higher-value tasks. However, these benefits are not automatic, and there are important caveats. AI systems must be trained and validated on representative data, and their outputs need to be monitored for accuracy and bias, particularly when used for decisions that carry financial, legal, or ethical implications. Organizations cannot simply assume AI outputs are correct. Best practice is to treat AI-generated classifications and extractions as draft work that should be reviewed by subject matter experts, especially during initial deployment. Over-reliance on AI without proper governance may introduce new risks, such as misclassification of sensitive data or incorrect metadata that propagates through retention and DLP policies. IDP does not eliminate the need for clear process and information architecture. If business processes are poorly defined or content is created in a chaotic manner, even the best models will struggle to impose order. AI amplifies whatever patterns exist. If those patterns are inconsistent, the generated metadata will be inconsistent and governance outcomes will remain unreliable. IDP should be positioned not as a silver bullet, but as a powerful enabler within a broader program that includes taxonomy design, governance frameworks, and change management. Within the Microsoft product suite, IDP capabilities are available across several products that serve different layers of the stack. Microsoft Syntex, now integrated into SharePoint Premium and document processing, operates directly on documents stored in SharePoint, enabling organizations to understand, classify, and extract information from their content within Microsoft 365. Syntex uses document processing models that can be configured to recognize structured forms, semi-structured documents, or unstructured content, and it integrates with SharePoint libraries to automatically apply metadata, content types, retention labels, and other governance artifacts. It also supports related capabilities such as content assembly, which can generate standardized documents from templates and data sources. Azure Document Intelligence, now part of Azure Content Understanding and Foundry tools, provides IDP capabilities as a cloud service that can process documents at scale and integrate with custom applications. It applies advanced AI models to extract text, key value pairs, tables, and document structure from files such as PDFs, images, and forms, with strong performance on structured and templated documents. The service exposes REST APIs for developers to analyze documents using pre-built analyzers, such as a general-purpose document analyzer that extracts text and layout elements like paragraphs and tables. This makes it suitable for scenarios where document processing needs to be tightly integrated with line-of-business applications, data pipelines, or external storage. Azure Content Understanding extends these capabilities beyond documents to other modalities, including images, audio, and video, providing pre-built analyzers for extracting transcripts, keyframes, and descriptions. A developer can send a file URL to a content understanding endpoint, specify an analyzer such as pre-built document analyzer or pre-built video analyzer, and then poll for analysis results, integrating the extracted data into downstream workflows. This positions content understanding as a general multimodal extraction layer within an AI architecture, complementing Syntex's focus on SharePoint content and user-facing automation. Azure Databricks, in turn, offers an intelligent document processing pattern built on its Lakehouse platform using natively composable AI functions to implement end-to-end IDP pipelines. This approach involves ingesting raw documents into the Lakehouse, parsing them into structured representations using functions like AI parse document, enriching them via functions such as AI extract and AI classify, and then leveraging the results for analytics, retrieval augmented generation, or agent workflows. Because each stage of the pipeline, ingestion, parsing, enrichment, and analysis is unified on the Lakehouse, organizations can avoid complex integration or data movement, while benefiting from Databricks' scalability and advanced analytics tooling. For most SharePoint-centric organizations, the choice is not between these platforms, but about how they complement each other. Syntex handles the SharePoint native automation. Azure Document Intelligence handles the API-driven bulk processing. Content Understanding handles the multimodal enrichment. Databricks handles the enterprise-scale analytics and machine learning refinement. The metadata schema is the common thread that ties them together. When every platform writes to the same taxonomy, the document becomes portable across systems, and the metadata becomes the single source of truth. A practical integration pattern starts with Syntex as the intake layer. Documents arrive in SharePoint, and Syntex extracts the core metadata. For simple automation, Power Automate reacts to the extracted values directly. For complex analytics, the metadata and document references flow to Azure Data Lake via Power BI Data Flows or Azure Synapse Link. For advanced machine learning refinement, Databricks reads the labeled documents, compares model predictions against human corrections, and generates improved training sets that feed back into Syntex. The loop is continuous. The document stays in SharePoint. The metadata serves every system. The taxonomy ensures consistency across the pipeline. The choice of processing platform also depends on latency requirements. Syntex processes documents synchronously as they arrive in SharePoint, making it ideal for real-time automation. Azure Document Intelligence can process large batches asynchronously, making it ideal for backlogs and migrations. Databricks handles scheduled analytics jobs that don't need real-time results. Architects who understand these latency profiles can design pipelines that use each platform for what it does best, rather than forcing one tool to handle every scenario. Syntex, SharePoint Premium, and document processing, the rebrand story. Microsoft has been building IDP capabilities directly into SharePoint for years. The problem is that they keep renaming the product, and if you're keeping score, this marks the fourth rebrand in just 6 years. Back in 2019, while still in development, it was called Project Cortex. A year later, it became SharePoint Syntex, focused on AI-powered document understanding. Then in 2022, it shifted to Microsoft Syntex as the company pushed content AI across workloads, not just SharePoint. At Ignite in November 2023, Jeff Teper introduced SharePoint Premium, a suite designed to help you manage, ground, and use content for AI. The idea was simple. One brand everyone could recognize, bringing together all the extra features on top of base SharePoint. SharePoint Premium was organized into 3 pillars: experiences, processes, and governance. For content experiences, it included brand new features like the Agreements app in Teams, SharePoint e-signature, and the Documents hub for customers and partners. The content processing pillar carried forward Syntex classics like Autofill columns, taxonomy tagging, content query, translation for both documents and videos, PDF annotations, and more. This is where you transform content with AI, not just to improve user experience, but also to prepare your content for Copilot. The better your content quality, the better your Copilot rollout will be. The governance pillar introduced advanced admin capabilities like SharePoint Advanced Management, Microsoft 365 Archive, and Microsoft 365 Backup. But now, almost 2 years later, here we are again. The funny part is that the rename from Syntex to SharePoint Premium wasn't even fully completed. As of late 2025, you could still see Syntex mentioned everywhere in the documentation and inside the admin center. Microsoft decided to split things up. SharePoint Advanced Management, Backup, and Archive are now standalone products. They're no longer under an umbrella. They're their own thing. Everything that used to be Syntex is now bundled under a new umbrella called Document Processing for Microsoft 365. And yes, Microsoft is very particular about branding. In the documentation, you'll notice it's written with a lowercase d and p because it's a category, not a product name. If you check Microsoft Learn right now, you'll see that this rename helps clarify their priorities. At the Microsoft 365 conference in May 2026, they named 4 services that will get the most attention going forward. Autofill columns, document translation, OCR, and e-signatures. These are their priorities. Meanwhile, older features from Syntex, like document processing models, content assembly, taxonomy tagging, and image tagging, have been pushed into the past generation's bucket. In the documentation, they're tucked away under other document processing services. Microsoft clearly doesn't want these to be seen as main services anymore. They're still available, but they're not part of the future roadmap. To be clear, Microsoft has not announced any plans to deprecate or stop supporting these older features. So if you're using them in production, don't worry, there's no emergency to move off them. But it's obvious which features will get the most love and investment moving forward. If you're relying heavily on older machine learning-based features like unstructured document processing models or content assembly, this is a good moment to start planning for the future. Look into whether newer tools like Autofill columns or Copilot can replace those features. It's not urgent, but moving in the same direction as Microsoft usually means you'll get newer features, a smoother experience, and maybe even cost savings. The operating model is changing, and architects need to understand what that means for existing investments. If you've already invested in Microsoft Syntex and built models, bound them to libraries, and wired Power Automate flows around them, you're not behind. You're actually in a better spot than tenants starting from scratch because the work you did is still valid and can be converted. But the operating model for that work is changing, and you need to develop a plan for what you can do moving forward. Nothing you built is wasted, but nothing you built is finished either. Treat this as a refresh, not a replatforming. The first step in that plan is inventory. Pull a list of every Syntex model in your tenant, what it is bound to, and what depends on its downstream output, flows, custom apps, and third-party integrations. Microsoft's reuse story is real, but it is a reuse story for the model. The shift from a human-trained model will not be one-to-one when moving to a large language model-based classification and extraction. You need to know which models are business-critical, which are experimental, and which have been abandoned. The second step is governance review. The libraries where you turned Syntex on were, by definition, libraries with high-value, structured content. Those are now the libraries Copilot and AI in SharePoint will reason over by default. Re-ask the questions that were used to build those models. Decide whether there are better AI in SharePoint features to execute the same governance actions. A model that classifies contracts might be replaced by an autofill column. A model that extracts invoice data might be replaced by a skill. The function might survive even if the implementation changes. The third step is mapping by feature. Use the one-to-one mapping from Microsoft documentation to figure out what you need to enable and learn with AI in SharePoint. Syntex autofill columns map to the new Create Autofill Columns experience. Document translation remains a metered content service with Copilot providing conversational entry points. OCR becomes part of the baseline AI-ready content pipeline. Content assembly shifts to template-driven generation in Content AI. Image tagging and taxonomy tagging are internalized into the broader AI-ready content concept. Pre-built, structured, free-form, and unstructured models all form the processing substrate for higher-level agent actions. Understanding this mapping prevents you from rebuilding what you already have. The fourth step is piloting skills somewhere boring. Skills are interesting. Agent-driven orchestration is genuinely new, and the Agent Assets Library deserves a real governance review before you let business-critical workflows live there. Pick a low-stakes site, an internal team that will not be hurt if something gets edited, deleted, or executed unexpectedly, and learn there. The interesting skills are the ones that touch content. The interesting failures are the ones that touch the wrong content. The fifth step is keeping the receipts. Don't tear down your Microsoft Syntex configuration documentation, your model training notes, or your cost baselines yet. We're in the middle of a transition, the meters still bill, and Microsoft moved. My cheese is going to be a recurring conversation with your finance partner. The documentation you have now is an asset you'll want later. It proves what you built, how much it cost, and what it delivered. That evidence is what secures budget for the next phase. Model types: structured, freeform, and unstructured. Behind all the branding changes, the core technology hasn't changed. It's still models. Microsoft defines several model types tuned to different classes of documents. Understanding which type fits your content is the first real decision you need to make. Structured document processing is for forms and layouts with predictable fields. Invoices, purchase orders, tax forms, and standardized applications all fall into this category. Because the fields appear in consistent locations and formats, structured models can map specific regions of a page to named columns, achieving high accuracy with relatively little training data. You upload a few sample documents, draw boxes around the fields you want, and the model learns to find those same fields on new documents. This is the fastest path to value. If your documents are mostly structured, start here. Freeform document processing sits in the middle. These are documents that contain fields in variable positions but with recognizable patterns. A statement of work might list deliverables, timelines, and budgets in different places depending on the client, but the language patterns are consistent. A health insurance claim might mix structured tables with freeform provider notes. Freeform models are backed by AI Builder and use a combination of layout understanding and language recognition. They require more training examples than structured models, but handle variability that rigid templates cannot capture. Unstructured document processing is the most complex and the most valuable for governance. Contracts, policies, memos, and correspondence lack fixed layouts and rely heavily on linguistic cues and context. An effective date might appear after the phrase, "This agreement is effective as of" in one contract and after commencement date in another. A liability cap might be expressed as a dollar amount, a percentage of revenue, or a multiple of fees. Unstructured models use natural language processing and machine learning to infer meaning from context, not just location. They need more training examples, more careful field definition, and more iterative refinement, but they are the ones that transform document dumps into governed, searchable, actionable libraries. For common business scenarios, Microsoft provides pre-built models that do not require training. These include models for contract processing, invoices, receipts, sensitive information, and simple documents. These pre-built models aim to accelerate value by addressing everyday document types without requiring organizations to label their own training sets, while still allowing customization where domain-specific needs arise. If your documents match one of these types, the pre-built model can get you live in hours instead of weeks. From a machine learning standpoint, unstructured document classification and extraction often use natural language processing models that encode text into numerical representations, using techniques such as term frequency or modern transformer-based embeddings. Models including naive Bayes support vector machines, logistic regression, and deep learning architectures like transformers or convolutional neural networks can then be trained to map these representations to labels such as document type or sensitivity, or to extract spans corresponding to entities. As organizations accumulate labeled examples from human review or syntax feedback, they can iteratively improve these models, whether through built-in training capabilities or external machine learning platforms. The choice depends on your documents. Start with pre-built if your documents match a standard type. Move to structured if your forms are consistent. Use freeform for semi-structured variability. Reserve unstructured for the complex narrative documents that carry the most business risk. And remember, you don't need a data science degree. The no-code interfaces in Syntex and AI Builder let subject matter experts label documents, define fields, and train models without writing code. The model learns from your expertise, not the other way around. Let's walk through a concrete decision scenario. Your finance department receives 500 invoices per month from 40 different vendors. Some vendors use their own templates. Others send PDFs generated from accounting software. A few still send scanned paper invoices. The header information is always present, but the line items vary in number and layout. The total amount might appear at the bottom right, in a summary box, or in a payment instructions block. This is a semi-structured problem. A structured model would fail on the vendor-specific variations. An unstructured model would be overkill and slower to train. A freeform model, possibly starting from the pre-built invoice processor, is the right fit. Now consider your legal department. They manage 2,000 active contracts, including master service agreements, statements of work, amendments, and non-disclosure agreements. Each law firm uses its own template. Some contracts are 50 pages, others are 5. Governing law might appear in a dedicated section, in a footer, or in a governing law rider attached as a separate document. There are no fixed layouts, no consistent field positions. The language varies between plain English and dense legalese. This is an unstructured problem. Only an unstructured document processing model can extract effective dates, termination clauses, liability caps, and renewal terms across this variability. The pre-built contract model gives you a head start, but you will need to customize it heavily for your organization's specific contract language. The machine learning behind these models is more accessible than most people assume. For structured and free-form documents, AI Builder uses a form recognizer that learns layout patterns from your labeled examples. It creates a geometric map of where fields typically appear and refines that map as it sees more documents. For unstructured documents, Syntex uses natural language processing models that encode text into numerical representations. These representations capture semantic meaning, not just keyword matching. The model learns that effective date and commencement date and start date are semantically equivalent in contract contexts. It learns that a dollar amount following liability shall not exceed is a liability cap, while a dollar amount following total amount due is an invoice total. This semantic understanding is what makes unstructured extraction powerful, and it is why the training data must include linguistic diversity, not just layout diversity. Model accuracy follows a predictable curve. With structured documents, you might reach 80% accuracy with 20 labeled examples and 95% with 50. With freeform documents, the curve is flatter. You might need 100 examples to reach 80% and 300 to reach 95. With unstructured documents, the curve is steeper and longer. You might need 200 examples to reach 70% accuracy and continuous iteration to push past 85. The organizations that succeed plan for this curve. They allocate time for multiple training cycles. They build feedback loops where users correct extractions and those corrections feed back into the model. They measure accuracy per field, not per document, because some fields are harder than others. A model that extracts invoice totals at 98% accuracy, but vendor names at 70% accuracy needs more training on vendor name variants, not more training on totals. AI agents, skills, and the new operating model. But choosing the model type is just the warm-up. The real work starts when you train it. And in 2026, the training environment itself just changed. The architectural shift that Microsoft is pushing is a move from feature-by-feature syntax configuration to conversational intent-based AI agents. Every SharePoint site now has an agent. The SharePoint admin agent monitors governance automatically, identifying inactive sites, flagging overshared content, tracking permission sprawl, and highlighting high-activity sites that may need additional attention as Copilot adoption grows. Rather than requiring manual intervention, the admin agent automatically applies policies such as archiving inactive sites or adjusting access permissions to reduce security risks. Site-specific agents create instant knowledge bases for every SharePoint site. These agents understand the content, structure, and purpose of their respective sites, allowing employees to quickly tap into relevant information without complex searches or navigation. Site agents can answer questions like, what are the key deliverables for the current quarter, by synthesizing information from documents, lists, and pages within their site. Organizations can also build custom agents directly within SharePoint using Copilot Studio integration. These agents connect to SharePoint lists, document libraries, and pages as knowledge sources, providing real-time access to current data. Custom agents handle specific business processes such as employee onboarding assistance, policy question answering, project status updates, or equipment request management, all without requiring extensive development resources. Skills are the new automation layer. A skill is a reusable AI workflow stored as a markdown definition in the site's agent assets library. Skills describe repeatable AI workflows over the site's content, such as review, enrich, or root operations. You write a skill in natural language, describing what you want to happen, and the agent executes it across the site. For example, you might write a skill that says, for every invoice uploaded to the finance library, extract the vendor name, invoice number, and total amount, then send a notification to the accounts payable team if the total exceeds $10,000. The skill chains extraction, metadata update, list operation, and notification into a single automated workflow. This sounds like the future, and in many ways it is. But there are drawbacks nobody is talking about. Skills have no version control and no rollback. They are stored as markdown in SharePoint. Edit and save, and it's live immediately. There is no Git history, no undo, and no sandbox environment. You write the skill, submit it, and it runs on real data. One mistake and you've modified thousands of records. And by default, everyone can create a skill. That is a governance problem waiting to happen. Autofill columns represent another major shift. In the Syntex era, you built a model, bound it to a library, and configured extractors. In the AI era, users just ask Copilot to fill library columns, no model galleries, no complex binding, just a natural language prompt. But autofill has its own limitations. Configurations live in your document library and can't be reused in another library. Each library requires its own separate setup. Testing is limited to one file at a time. With thousands of files, you're flying blind. And when you run batch prompt testing, there's no preview of what's actually happening. You submit the batch and hope it works. No visibility into errors or extraction quality until it's too late. There is also a critical architectural gap. There is no native ability to perform sensitivity and retention labeling with AI in SharePoint currently. The agents and skills can extract metadata, classify documents, and update columns, but they do not natively apply Purview sensitivity labels or retention policies. That means organizations still need SharePoint's native governance controls, Power Automate orchestration, or custom integrations to bridge the gap between extracted metadata and enforced compliance. The AI layer handles extraction and classification. Purview handles enforcement. And the connection between them is still manual. The one-to-one mapping from Syntex to AI in SharePoint is helpful for architects trying to manage the transition. Syntex Autofill columns map directly to the new Create Autofill columns experience in AI-enabled libraries. Document translation remains a metered content service, with Copilot providing conversational entry points for ad hoc translation. OCR becomes part of the baseline AI-ready content pipeline, triggered when users initiate interactions rather than running automatically on every upload. Content assembly shifts to template-driven document generation in Content AI, combined with Copilot-driven content generation. Image tagging and taxonomy tagging are internalized into the broader AI-ready content concept, surfaced through improved search and autofill rather than standalone configurations. Pre-built, structured, freeform, and unstructured models all form the processing substrate for higher-level agent actions. What this means in practice is that your existing Syntex models are not wasted. They still build through Azure pay-as-you-go meters. They still run, they still extract, but their role is shifting from primary user interface to back-end substrate for agent actions. The user-facing experience is now conversational, the configuration experience is now intent-based, and the governance experience is now distributed across every site in your tenant. That is a structural change, not a cosmetic one. Architects who understand this shift will design solutions that survive the transition. Those who don't will find their carefully trained models orphaned behind a user interface that no longer exists. The knowledge agent is another major piece of this puzzle that entered public preview in September 2025 and reached general availability in early 2026. It is included with Microsoft 365 Copilot licenses at no extra cost. Knowledge Agent uses artificial intelligence to automatically tag and classify documents with metadata, eliminating hours of manual data entry. When you upload financial reports or project plans, the agent analyzes content and suggests relevant metadata columns, ensuring consistent organization across libraries and sites. Early adopters like Mars Inc. called the auto-filled metadata capability a total game changer, drastically reducing time spent on manual categorization. The agent also continuously monitors SharePoint environments to maintain content quality. It identifies broken links, flags outdated pages, detects duplicate content, and locates missing information that users are searching for but cannot find. Rather than waiting for manual audits, Knowledge Agent proactively keeps your SharePoint instance clean and current. A floating button appears throughout SharePoint surfaces, providing role-specific actions based on what you're working on. Site owners see options to improve their sites and fill content gaps, while content creators receive suggestions for metadata enrichment and automated workflows. Automated workflow creation is where the agent gets genuinely powerful. You describe what you need in natural language, such as identifying new invoices exceeding a specific threshold, and Knowledge Agent builds the workflow automatically. This removes the technical barrier to automation, allowing business users to create sophisticated processes without coding knowledge. But this power comes with the same governance warnings that apply to skills. A workflow built by an agent is still a workflow running on real data. If the description is ambiguous, the result might be wrong. If the threshold is misstated, the notification goes to the wrong person. Natural language is fast but imprecise. Precision requires governance. The SharePoint Page Agent enables users with Microsoft 365 Copilot licenses to create and refine SharePoint pages using natural language. Rather than manually building page layouts and adding web parts, content creators describe what they need, and the agent generates professionally designed pages that match organizational branding and standards. This accelerates content creation dramatically, but it also raises questions about content quality and consistency. An AI-generated page might look correct while containing outdated policy language or incorrect contact information. Human review remains needed, especially for pages that serve as authoritative sources for Copilot grounding. Custom no-code agents built through Copilot Studio integration represent the most flexible layer of this new architecture. Organizations can create agents that connect to SharePoint lists, document libraries, and pages as knowledge sources, providing real-time access to current data. These agents handle specific business processes such as employee onboarding assistance, policy question answering, project status updates, or equipment request management. Because they live inside the SharePoint environment, They can reference current data without the latency of external integrations. But they also inherit the permissions and visibility rules of the sites they access. An agent that answers questions about salary ranges must respect the permissions of the HR site it queries. An agent that summarizes project status must not expose confidential client information from a restricted library. Agent governance is site governance, and the two cannot be separated. Building your first custom document processing model. Building a custom model that survives this transition is less about machine learning theory and more about document archaeology. You need to understand your content before the machine can. Step 1 is auditing your documents. Pull a representative sample of every document type you want to process. If you're starting with contracts, gather master service agreements, statements of work, non-disclosure agreements, and amendment documents. Include the good scans, the bad scans, the digital Word files, and the PDFs that somebody printed and scanned back in. The model needs to see the mess, not just the clean examples. Diversity matters more than volume. 100 varied documents teach more than 1,000 identical ones. Step 2 is designing the taxonomy first. Before you open the model builder, open a whiteboard. List every column your library needs. Contract type, counterparty name, effective date, expiration date, governing law jurisdiction, liability cap, auto-renewal flag, termination notice period. Each of these fields maps to a SharePoint column, and each column needs a data type and a vocabulary. If you're using managed metadata, define your term sets now. If you're using choice columns, list the options. The model isn't the hard part, the taxonomy is, and if your taxonomy changes after you've trained the model, you're retraining. Step 3 is selecting and uploading your training set. In the Syntex Model Builder or AI Builder interface, you upload your sample documents and begin labeling. For structured and freeform models, you draw bounding boxes around the fields you want to extract. For unstructured models, you highlight text spans and assign them to named entities. The interface is visual and requires no code. A contract manager or legal analyst can do this work. The model learns from their expertise. Step 4 is defining your entities with precision. An expiration date is not just any date on the page, it's the date after the phrase "this agreement shall terminate on" or the date in the terms section. A liability cap is not just any dollar amount. It's the number after "liability shall not exceed" or cap on damages. The more precisely you define the linguistic context around each field, the more accurately the model will extract it. Vague field definitions produce vague results. Step 5 is training, testing, and validating. The model builder splits your labeled documents into training and test sets automatically. After training, you review the confidence scores for each extraction. A confidence score above 80% is generally reliable for automated processing. A score between 50 and 80% should flag for human review. Below 50%, you need more training examples or better field definitions. Test on documents that weren't in your training set. Test on the edge cases. Test on the blurry scans and the odd formatting. If the model fails there, it will fail in production. The no-code promise is real. Subject matter experts can build these models without writing Python or understanding neural network architecture, but the no-code label is misleading in one important way. It doesn't mean no expertise. It means the expertise is domain expertise, not data science. The person labeling contracts needs to understand contract structure. The person defining entity extractors needs to know where expiration dates hide in their organization's documents. The model learns from human pattern recognition. If the human doesn't recognize the pattern, the machine won't either. Microsoft provides pre-built models that accelerate this process for common scenarios. The pre-built contract processing model can identify contract type, parties, dates, and other standard elements without requiring extensive training. The pre-built invoice and receipt models extract totals, dates, and vendor information. If your documents match these patterns, start with the pre-built model and customize from there. You'll get to production faster, and you'll have a baseline for accuracy that you can improve iteratively. Pay-as-you-go billing means you only pay for what you process. Each page, sheet, slide, or file transaction is metered through your attached Azure subscription. This makes it feasible to run proof-of-concept projects without committing to large upfront licenses. Process a few hundred documents, measure the accuracy, calculate the time savings, and build the business case from real data. The meters continue to exist behind the scenes in the AI era, and Azure Cost Management lets you monitor consumption as you scale. There is a critical limitation you need to plan for. Autofill configurations in the AI era live in your document library. You can't reuse them in another library. Each library requires its own separate setup. There is no sharing, no inheritance. If you have 50 contract libraries across your tenant, you may need 50 separate configurations. That is not a scaling model. It is a point solution. For enterprise deployment, you need to think about whether the new autofill approach fits your architecture or whether you should stick with classic syntax model binding that can be applied across libraries via content types. Power Automate remains the connective tissue between extracted metadata and downstream action. When a syntax model extracts an expiration date, a Power Automate flow can read that column value, calculate the 90-day warning threshold, create a planner task, and send an email to the contract owner. When a model classifies a document as containing personal data, a flow can trigger a sensitivity label application, log the event to a compliance register, and notify the data protection officer. These orchestrations are not optional extras. They are what turns extracted metadata into business process automation. Error handling in production workflows is often overlooked during pilot deployments. Your production flows need branches for model failures, low confidence scores, corrupted files, and password-protected PDFs. A missing expiration date should not create a blank task. A low confidence extraction should route to a human reviewer queue. A processing failure should log to an admin dashboard, not silently drop the document. Build these exception paths before you scale, because exceptions become common at volume. Document quality is another production reality that pilots often ignore. A training set of pristine digital PDFs produces a model that fails on the fax-scanned, coffee-stained, sideways-oriented documents that arrive in production. Your intake process needs quality gates. Reject scans below 300 dots per inch, flag documents with missing pages, alert users when a file is encrypted or password protected. The model cannot process what it cannot read, and failed processing costs money without delivering value. A small amount of intake validation prevents a large amount of downstream rework. Integration with external systems is where the architecture gets interesting. Documents arrive through email, third-party portals, migration batches, and API uploads. Each of these channels needs to land the file in a SharePoint library, trigger the model, and handle the metadata output consistently. A common pattern is to create a staging library for incoming documents, run the model there, and then move the classified document to its final destination library based on the extracted metadata. This decouples intake from storage, allowing you to apply different processing rules to different document sources without complicating the destination libraries. Monitoring and telemetry complete the production picture. Azure Application Insights can track model performance, processing latency, and error rates. SharePoint audit logs record who uploaded what, when the model ran, and what metadata was applied. Power BI dashboards can visualize throughput, accuracy trends, and cost per document. These monitoring layers are not just for troubleshooting, they are for continuous improvement. When accuracy drops, the dashboard tells you. When costs spike, the alert fires. When a new document type appears in the intake, the pattern detection flags it for model retraining. Entity extraction. Deep dive. The technical core. Entity extractors are where beginners become professionals. Simple field mapping finds text in a fixed location. Entity extraction finds text based on context, pattern, and meaning. That difference is everything when you're processing contracts, policies, and legal documents. Let's start with a concrete example. A master service agreement might contain an effective date. In one document, it appears after, "This agreement is effective as of January 15, 2024. In another, it appears after commencement date, 15th January 2024. In a third, it appears in a table labeled Key Terms with a row for start date. A simple field mapper would miss two of these three instances. An entity extractor trained on the linguistic patterns around effective dates would catch all three. The extractor works by learning the relationship between a label and a value. You highlight multiple examples of the same entity across different documents, and the model generalizes the pattern. It learns that effective dates often follow phrases like effective as of, commences on, start date, or term begins. It learns that expiration dates follow terminates on, end date, expiration, or renewal deadline. The more examples you provide, the stronger the pattern recognition becomes. Liability clauses are another high-value extraction target. A liability cap might be expressed as a fixed dollar amount, a percentage of fees paid, a multiple of annual charges, or an insurance coverage limit. The extractor needs to understand that liability shall not exceed $500,000 and total liability capped at $500K and damages limited to the greater of $500,000 or 12 months of fees all represent the same conceptual entity. You train this by labeling each variant and letting the model learn the semantic equivalence. Termination clauses require similar semantic understanding. Some contracts terminate on a fixed date, others terminate after a notice period, others terminate upon a material breach, others auto-renew unless one party provides written notice. Each of these represents a different termination pattern, and your taxonomy needs columns that capture the distinction. A single end date column is insufficient. You need termination type, notice period, auto-renewal flag, and renewal notice deadline. The richness of your taxonomy determines the richness of your extraction. Confidence scores are your quality control mechanism. When the model extracts a value, it assigns a confidence score between 0 and 100. You need to set thresholds that match your risk tolerance. For low-risk extractions like document type classification, an 80% threshold might be acceptable. For high-risk extractions like liability caps or governing law, you might want 95% confidence before auto-accepting anything below that flags for human review. Don't set one threshold for everything. Match the threshold to the business consequence of an error. Handling variability is where most models fail in production. Documents that looked clean in training arrive in production with handwritten annotations, stamp overlays, fax headers, or rotated pages. The model needs to see these variants during training. Include at least 10% of your training set as edge cases and bad examples. If you only train on pristine documents, your model will be a pristine failure. Scanned PDFs present a specific challenge. Optical character recognition transforms the image into text before the model processes it. But OCR quality varies with scan resolution, font clarity, and page rotation. A document scanned at 200 dots per inch might produce garbled text, where a 300 dots per inch scan produces perfect extraction. If your document pipeline includes a lot of scanned paper, test your OCR layer separately from your extraction layer. Bad OCR produces bad extractions, and the extraction model gets blamed for a problem that happened upstream. Common training mistakes follow predictable patterns. Too few edge cases produces a model that only works on ideal documents. Overfitting to one template produces a model that fails when a new vendor sends a different layout. Ignoring negative examples, documents that don't contain the entity at all, produces a model that hallucinates extractions where none exist. The cure for all of these is more representative training data and iterative validation. Iteration is not a sign of failure, it is the process. Deploy your model to a pilot library, process a few hundred real documents, review the extractions, and feed the corrections back into the training set. Every corrected extraction makes the model smarter. Every false positive teaches it what to avoid. Plan for at least 3 training cycles before you call a model production ready. The organizations that get the best results treat model training as a continuous improvement process, not a one-time setup task. Multi-page documents present extraction challenges that single-page models do not. A contract might have the effective date on page 1, the liability clause on page 8, and the signature block on page 12. The model needs to understand that entities can appear anywhere in the document, not just on the first page. When you label training examples, make sure to label entities on every page, not just the page where they most commonly appear. A model trained only on page 1 extractions will miss page 8 data in production. Tables are another common pitfall. Contracts often include schedules, pricing tables, and responsibility matrices. A simple entity extractor might see a table cell containing a date and incorrectly label it as the effective date when it is actually a delivery milestone from a schedule. You need to train the model to recognize table boundaries and distinguish between header rows, data rows, and footer summaries. Some extraction problems are better solved by table extraction than by entity extraction. If your document contains a recurring table structure, such as a monthly payment schedule, consider whether a structured or free-form model would capture that table more reliably than an unstructured entity extractor hunting for isolated values. Signatures and handwritten annotations break many extraction pipelines. A scanned signature might cover a date field, making OCR fail. A handwritten note in the margin might contain a critical amendment that the model ignores because it only processes printed text. If your document pipeline includes heavily annotated documents, you need to decide whether to extract the annotation layer separately or to train the model to recognize handwriting. Neither approach is trivial, and both require higher quality scans than pure printed text extraction. Cross-document entity resolution is the advanced challenge that separates basic extraction from true document intelligence. Suppose you have a master service agreement and 5 associated statements of work. The MSA contains the governing law and the liability cap. Each SOW contains the project scope, timeline, and budget. Your taxonomy needs to capture the relationship between these documents. A standalone extraction of the SOW budget is useful, but an extraction that links the SOW to its parent MSA and inherits the governing law from the MSA is far more powerful. This requires not just document-level extraction, but document relationship modeling, which is beyond the current native capabilities of Syntex and requires custom orchestration through Power Automate or Azure Logic apps. Language and jurisdiction variations add another layer of complexity. A global organization might process contracts in English, German, Japanese, and Portuguese. The pre-built models handle some of these languages, but custom models need language-specific training. A termination clause in English uses different linguistic patterns than a clause in German. You cannot train a model on English contracts and expect it to extract accurately from Japanese contracts. You need separate models for each language, or you need to use Azure Document Intelligence's multilingual capabilities as a pre-processing layer before syntax extraction. The metadata schema, however, can be shared across languages. The contract type column means the same thing whether the document is in English or Japanese. This is why taxonomy design must be language agnostic even when model training is language specific. Testing protocols for production readiness should include a formal validation suite. Select 100 documents that represent your full production mix, including clean digital files, scanned paper, multi-page contracts, tables, signatures, and edge cases. Run these documents through the model and compare the extractions against a human-verified ground truth. Calculate precision, recall, and F1 score for each field. Publish the results to the Governance Council. If accuracy is below your threshold, do not deploy. Retrain and retest until the numbers meet your standard. This discipline separates experiments from production systems. Deploying to live libraries, autofill, and skills. Once the model is trained, you need to connect it to live workflows. In the classic Syntex model, you publish the model and bind it to a SharePoint library. Every time a document is uploaded to that library, the model runs automatically. It classifies the document type, extracts the fields, and populates the library columns. The process happens in seconds, and the user sees the metadata appear as if by magic. That binding mechanism still works. And for multi-library deployments, it is still the most scalable approach. In the AI era, the experience is different. Users open a document library, select Create Autofill Columns, and describe what they want in natural language. Copilot processes the documents and suggests column values. There are no model galleries, no complex binding, no extractors to configure, just a prompt. The trade-off is flexibility for simplicity. You lose the ability to reuse the configuration across libraries. You lose batch testing visibility, but you gain speed and accessibility. Real-time classification means that the moment a file hits the library, the metadata is generated. For high-volume libraries processing hundreds of documents per day, this automatic processing is critical. Documents can also be processed via API, which means that files uploaded through third-party systems, email attachments, or migration tools can still trigger the same extraction pipeline. The metadata schema is consistent regardless of how the document arrived. Multimodal inputs are increasingly common. Your contract library might contain digital Word files, scanned PDFs, image attachments, and even photographs of signed documents taken on a phone. The OCR layer handles the image-to-text conversion, and the extraction model processes the resulting text. The user experience is the same. The underlying pipeline adapts to the input type automatically. What matters is that the extraction quality depends on OCR accuracy for scanned inputs, so monitor your scan quality as part of the deployment. Connecting extracted metadata to views and filters transforms the library from a file dump into a business dashboard. Create views that show contracts expiring in the next 90 days. Create views that filter by governing law jurisdiction. Create views that flag auto-renewal contracts approaching their notice deadline. These views turn metadata into action. A legal team can open SharePoint and see exactly what needs attention today without running a single manual search. Skills take this a step further by automating workflows across the entire site. A skill might say, for every contract uploaded to the legal library, extract the counterparty name and expiration date, create a calendar event for 90 days before expiration, and notify the contract manager. The skill is written in natural language, stored as Markdown in the agent assets library, and executed by the site agent. It chains extraction, metadata update, list operation, and notification into a single automated workflow that runs without human intervention. But production deployment requires caution. Skills have no version control. Edit the Markdown, save it, and it's live. There is no rollback. There is no sandbox for testing. You write the skill, submit it, and it runs on real data. One syntax error, and you've modified thousands of records. And by default, everyone can create a skill. Before you enable skills in a production site, restrict creation to designated owners. Before you deploy a skill to a high-stakes library, test it on a copy of the data. The speed of skills is a double-edged sword. Fast execution means fast mistakes. You also need to monitor costs. Azure pay-as-you-go meters track every page processed, every translation character, every signature request. The meters are granular and transparent, but they accumulate quickly at scale. Set up Azure cost management alerts before you go live. Process a pilot batch, measure the metered cost per document, and extrapolate to your full volume. A surprise Azure bill is not the kind of production feedback your finance team wants. Search configuration is an often overlooked benefit of populated metadata. SharePoint Search uses crawled properties and managed properties to index content. When your model populates a managed metadata column, that value becomes a managed property that Search can filter, refine, and query. Users can search for contract type, MSA, and find every master service agreement in the tenant. They can search for expiration date now to now 90 days and find every contract expiring in the next 90 days. These are not advanced queries. They are standard search syntax that becomes powerful when metadata exists. Without metadata, search is limited to full-text keyword matching, which returns noise. With metadata, search becomes precision retrieval. The user experience of automated metadata population also drives adoption. When a user uploads a contract and sees the expiration date, counterparty name, and contract type appear automatically in the library columns, they understand the value immediately. When they see empty columns that require manual tagging, they skip the step. The model's accuracy directly affects user trust. If the model populates columns correctly 9 times out of 10, users learn to trust the 10th. If it fails 5 times out of 10, users learn to ignore it. Accuracy is not just a technical metric, it is an adoption metric. Migration scenarios are another place where deployment planning matters. If you are migrating documents from a file share or a legacy document management system into SharePoint, you have a one-time opportunity to apply metadata during the migration. Tools like SharePoint Migration Manager can map source properties to destination columns. But most source systems have no structured metadata. They have folder paths and file names. You can use the folder path as a hint, mapping file share contracts to 224 bars to a contract year column. But the real value comes from running the Syntex model on the migrated documents after they land in SharePoint. Plan the migration in 2 waves. First, move the files. Second, process them with the model. The model will populate columns that the migration could not. Disaster recovery and business continuity also depend on metadata. If a site is accidentally deleted and restored from backup, the documents return, but the model bindings might not. If the model was bound to a library that no longer exists, the restored library might not have the same binding. Document your model library relationships. Include them in your backup and recovery runbooks. Test restoration in a sandbox environment. A model that worked perfectly before a disaster and failed silently after recovery is not a resilient system. Metadata governance includes disaster planning, not just day-to-day operations. From metadata to governed action. Extracted metadata is just data until you enforce something with it. The real transformation happens when you connect those library columns to policies, workflows, and compliance controls. Retention labels in Microsoft Purview are the first place to connect. When your model extracts an expiration date and writes it to a SharePoint column, you can configure a retention policy that triggers 6 months before that date. The document is flagged for review, the owner is notified, and the organization makes a conscious decision to renew, renegotiate, or dispose. Without that connection, contracts expire silently, auto-renew by default, or sit in storage long past their useful life. Retention without metadata is a blunt instrument. Retention with extracted metadata is a precision tool. Sensitivity labels work the same way. When your model classifies a document as containing personal data, financial records, or intellectual property, that classification can trigger a sensitivity label that restricts external sharing, encrypts the file, or applies a watermark. The classification happens automatically at upload. The protection follows immediately. Users don't need to remember which documents are sensitive. The model remembers for them. Data loss prevention policies benefit enormously from accurate classification. DLP rules detect and protect sensitive information across Microsoft 365 locations. They use predefined or custom sensitive information types and can take actions such as blocking external sharing, sending alerts, or requiring justification for policy overrides. But DLP is only as accurate as the classification feeding it. When documents carry reliable metadata generated by trained models, DLP policies trigger on the right documents and ignore the false positives. When metadata is missing or wrong, DLP becomes a nuisance that users bypass. Legal hold scenarios demonstrate the full value of governed metadata. When litigation is anticipated, legal teams need to identify, preserve, and produce all relevant documents. Without metadata, that means manual review of every file and every site. With metadata, it means filtering by document type, date range, counterparty, and custodian. A well-classified SharePoint environment reduces e-discovery from weeks of manual labor to hours of targeted export. The chain of custody is documented automatically, the metadata integrity is preserved, the defensibility is stronger. Dashboard visibility closes the loop for business stakeholders. Power BI can connect directly to SharePoint lists and libraries, visualizing the extracted metadata in real time. Executives see contract renewal pipelines. Compliance officers see retention status across departments. Security teams see sensitivity label coverage. The documents that were once invisible become the data source for strategic decisions. The metadata gap that was a liability becomes a competitive advantage. And the digital trail is complete. Every extraction, every column update, every policy application, and every user access is logged in SharePoint audit records. When an auditor asks how you knew which documents to retain, you show them the model that extracted the expiration date and the policy that applied the label. When a regulator asks how you protected sensitive data, you show them the classification model and the sensitivity label automation. The metadata doesn't just organize your content, it proves your governance. Workflow automation triggered by metadata is where the operational value becomes tangible. When a model extracts a contract value and writes it to a SharePoint column, a Power Automate flow can evaluate that value against approval thresholds. A contract under $10,000 might route to a department manager for approval. A contract over $100,000 might route to legal, finance, and the CFO in sequence. The routing logic is driven by the extracted metadata, not by manual form submissions. The metadata becomes the workflow engine. Document lifecycle management also improves dramatically. Most organizations have a loose concept of document lifecycle, but they lack the mechanism to enforce it. A contract might have 6 lifecycle stages: draft, under review, approved, executed, active, and expired. Each stage has different permissions, different retention rules, and different notification requirements. With metadata-driven lifecycle management, the stage is a SharePoint column populated by the model or by workflow logic. When the model detects signatures on the final page, it updates the stage to executed. When the expiration date passes, the workflow updates the stage to expired and triggers a retention review. The document moves through its lifecycle automatically, guided by the metadata it carries. External collaboration scenarios benefit from metadata-driven access control. When you share a document with an external law firm or audit partner, you need to know what you are sharing. A document tagged with client confidential and legal privilege requires different sharing controls than a document tagged with public reference material. Metadata-driven sharing policies can enforce these distinctions automatically. The model classifies the document at upload. The sensitivity label applies the sharing restriction. The external recipient receives only what they are supposed to receive, and the organization maintains an audit trail of what was shared, why, and when. Version control and document history also improve with metadata. When a contract goes through 5 revision cycles, the version history shows what changed, but it doesn't explain why. A metadata column for approval stage can show that version 2 was the legal review draft, version 3 included finance feedback, and version 4 was the final executive approval copy. The version history tells you when. The metadata tells you why. Together, they create a complete narrative of the document lifecycle that satisfies auditors, protects the organization in disputes, and educates new team members about how decisions were made. Training and compliance reporting also rely on metadata. Regulatory frameworks often require evidence that employees have read and acknowledged policies. A policy document tagged with acknowledgement required an employee handbook can trigger a training workflow that assigns the document to every new hire and tracks their acknowledgement. The metadata drives the assignment list. The workflow tracks the completion status. The audit report shows who has acknowledged which policies and when. Without metadata, this becomes a manual mailing list and a spreadsheet that nobody updates. The cumulative effect of these connections is that SharePoint stops being a file repository and starts being a business system. Documents are not passive storage. They are active records that trigger workflows, enforce policies, generate reports, and drive decisions. The metadata is what makes this transition possible, and the model is what generates the metadata at scale. Scaling AI transformation across the enterprise. One library is proof of concept. The real return comes when you scale, but scaling requires more than copying the model to another site. It requires a strategy, a governance framework, and a change management plan. Start by measuring what matters. Before you expand, establish baseline metrics for your pilot. How many documents were processed? What was the average extraction accuracy? How many hours did staff spend on manual data entry before the model and how many after? How many compliance incidents were prevented by automated retention? These numbers build the business case for expansion. Without them, you're asking for budget based on faith. The ROI calculation combines time saved, error reduction, and risk avoidance. Industry benchmarks suggest that automated document processing can reduce processing time by 70% and error rates by 80%. But these are assumptions, not guarantees. Your actual results depend on document quality, model accuracy, and process maturity. Measure your own results. Use the pilot data to build a custom ROI model that reflects your organization's reality, not a vendor's best-case scenario. Expanding from legal to finance, HR, and operations follows a pattern. Identify the next document type with high volume, high manual effort, and high business risk. Finance might process invoices and purchase orders. HR might process employee agreements and benefits forms. Operations might process safety reports and vendor certifications. Each domain has its own document patterns, its own taxonomy, and its own compliance requirements. Don't assume the contract model transfers directly. Train a new model for each document type using domain experts from that department. Change management is the most underestimated part of scaling. The technology is the easy part. The hard part is getting people to trust it. Contract managers need to see that the model's extractions are accurate before they stop manually checking every field. Legal teams need to understand that the retention policy is defensible before they rely on it for e-discovery. IT teams need to know that the model won't generate surprise Azure bills before they let it run unattended. Trust is built through transparency. Show people the confidence scores. Show them the correction workflow. Let them override the model when it's wrong, and feed those corrections back into training. Governance councils become critical at scale. A single model in one library can be managed by one owner. 50 models across 10 departments need coordination. Establish a cross-functional governance council with representatives from IT, legal, compliance, and business units. Define who owns the term sets, who approves new models, who monitors accuracy, and who handles exceptions. Without this structure, models proliferate inconsistently, taxonomies diverge, and the metadata gap reappears at a larger scale. The roadmap is simple. Audit your current workflows and identify the highest impact document type. Pilot a model for that type in a single library. Measure accuracy, cost, and time savings. Iterate on the training data until the model is production ready. Connect the extracted metadata to retention, sensitivity, and DLP policies. Measure compliance outcomes. Then expand to the next document type and the next, until the entire document lifecycle is governed. This is not a big bang transformation. It is a series of deliberate, measured steps that compound over time. Department-specific expansion requires different planning for each domain. Finance departments typically start with invoices and purchase orders because these documents have high volume, consistent structure, and direct cost impact. The ROI is easy to calculate. Multiply the number of invoices per month by the minutes saved per invoice by the fully loaded cost per minute. The result is a monthly savings number that justifies the model investment. HR departments often start with employee agreements and benefits enrollment forms because these carry compliance risk. A misfiled I-9 form or an unsigned non-compete agreement creates legal exposure that is easy to quantify. Operations departments might start with safety incident reports or vendor qualification documents because these tie directly to insurance and audit requirements. Each department has its own pain point, its own document type, and its own success metric. Don't impose a single template. Let each department solve its own highest priority problem first. Technology adoption curves vary by department and by role. Early adopters in IT and legal might embrace the model immediately. Skeptics in finance and operations might resist until they see proof. Plan for this variation. Identify your champions in each department. Give them early access to the pilot results. Let them become internal advocates. When a contract manager tells her colleagues that the model saved her 4 hours last week, that testimony is more powerful than any business case presentation. Peer influence drives adoption more effectively than top-down mandates. Training programs need to cover 3 audiences. End users need to know how to upload documents and how to verify automated extractions. They need to understand what the confidence score means and when to override the model. Site owners need to know how to configure libraries, bind models, and create views. They need to understand taxonomy basics so they don't break the model by changing column names. Administrators need to know how to monitor costs, manage model versions, and enforce governance rules. Each audience needs a different depth of training, and each needs hands-on practice with real documents from their own department. Generic training on sample documents fails because it doesn't reflect the messiness of real-world content. Executive sponsorship is the single biggest predictor of scaling success. Without a senior leader who believes in the value of metadata governance, the project becomes an IT experiment that dies when the initial budget runs out. With executive sponsorship, the project becomes a strategic initiative that survives reorganizations, budget cuts, and staff turnover. The sponsor does not need to understand transformer models or Azure meters. They need to understand that unmanaged documents are a liability, that AI can fix it, and that the fix requires sustained investment in taxonomy, training, and governance. Their job is to protect the program long enough for the compounding benefits to become visible. Metrics and reporting sustain the program over time. After the pilot, establish a governance dashboard that tracks the metrics that matter to your organization. Document volume processed per month. Average extraction accuracy by field. Cost per document processed, hours saved per department, compliance incidents prevented, audit findings resolved. Share this dashboard monthly with the Governance Council and quarterly with executive leadership. When the numbers improve, celebrate the progress. When the numbers stall, diagnose the problem. Visibility creates accountability, and accountability creates improvement. The organizations that succeed treat this not as a technology deployment, but as a capability build. Technology changes, models get renamed, interfaces evolve. The capability that endures is the organization's ability to classify its content, govern its metadata, and automate its document processes. Build that capability, and you will survive every rebrand. Build only a point solution, and you will be rebuilding when the next rename arrives. Finally, consider the platform around your SharePoint deployment. Microsoft 365 is not a collection of separate products. It is an integrated platform where SharePoint, Teams, Outlook, OneDrive, Power Platform, and Purview share data, permissions, and metadata. When you fix the metadata gap in SharePoint, you improve the signal for Copilot in Teams, for Power BI in Outlook, and for Purview across the entire tenant. The metadata you extract from a contract in SharePoint today becomes the data that drives a Power Apps approval workflow tomorrow, a Power BI risk dashboard next quarter, and a Copilot answer 6 months from now. The investment in taxonomy and governance pays dividends across every workload in Microsoft 365. That is why the metadata gap is not just a SharePoint problem, it is a platform problem. And fixing it is not just an IT project, it is a business transformation. And remember, nothing you built is wasted, but nothing you built is finished either. The Syntex era has ended, but its capabilities live on as part of AI in SharePoint. Your existing models still build, still run, and still extract, but their behavior has changed. The user interface is conversational. The configuration is intent-based. The governance is distributed across agents and skills. Treat this as a refresh, not a swap. Validate before production. Plan for continuous iteration. And build your architecture so that it survives the next rename, because there will be one. The metadata gap is not a technology problem. It's a structural problem that technology can fix if you build the foundation first. Custom AI document models turn your SharePoint liability into a governed, searchable, Copilot-ready asset. But the model is only as good as the taxonomy it feeds, and the taxonomy is only as good as the governance that maintains it. If this changed how you think about SharePoint, follow me on LinkedIn. And if you want the next detailed look at Power Automate orchestration for extracted metadata, that's coming next.